Hello and welcome to the next episode of EVM programming course, and this episode we are looking into how to interact with smart contracts and how our transactions are used to change the state of EVM. So first, what are the possible ways of interacting with EVM blockchain? Actually, there is really only one way. This is JSON RPC. This is the core communication protocol that EVM is using. Of course, you can use like your crypto wallets to do that. You can use CLI, but at the end of the day, what is being sent is JSON RPC call. Here we have our official reference to the JSON RPC API. You can see here to the right that there are multiple ways in which we can call EVM node. Of course, I will add this URL to the video so that you can just check for yourself. But you can see that you have multiple operations that are just querying the node, and you don't have to pay for it. So actually, everything that is not transaction is free. If you want to get balance, you are just calling the node and it returns you balance. You don't have to pay for anything. The same for getting the storage of specific contract at given point. The same with reading, for example, transaction code for specific address, and on and on and on and on. You can actually, for example, use the if call to execute your transaction on the current state of EVM, but without applying the state. So this is like a just dry run. So you can try something out without really executing it. This is super useful if you want to simulate something. For example, testing frameworks are using it. However, if you want to perform any state to the EVM, you have to either send transaction or send raw transaction, which was signed before. And then like the parameters that we discussed before, you are having the from address, the recipient, amount of gas that you are willing to spend, the gas price that you are willing to pay for it, the amount of native currency that you are sending together with the transaction, and finally the input data that you are sending together with the transaction. After the transaction is being executed, you can then get the transaction receipt, which is just the result of the transaction. So it might be successful or reverted. It may also have additional logs or another useful information. Now, as I said before, the only way to modify the state of the blockchain is by using transaction. And you have two types of transaction: creating smart contract and calling smart contract. But we already discussed that before. But now we did not answer it in detail what smart contract really is. So this is just a executable code that is being created by create opcode or by transaction. You have to know here that if you are creating smart contract directly from externally owned account and your transaction is creating smart contract, for the EVM, it looks like if you use the create opcode to create. So you cannot create a smart contract in create to fashion directly by sending EOA transaction. Of course, you can use some intermediary contract that will use create to create the smart contract for you. And last, of course, the smart contract is immutable. But now, what really happens when the user sends transaction to create a new smart contract? So let's say that the user wants to create this smart contract that has just like one constructor and simple functions. If we go to the compilation details, we have some useful information about, for example, bytecode and runtime bytecode. It might be strange to you. Why is this difference? You have to know that the create opcode requires you to send the specific runnable code that will return to you what has to be deployed on chain. So the assembly code that will be prepared from Solidity compiler will be a set of instructions. For example, okay, let's initialize this value, this and that, and then you put to the memory what has to be deployed on chain, and then you return it. And this return value, the offset and length of the bytes, tells the EVM what to deploy on chain. So this is a bit tricky to understand, but this is why the constructor is not deployed, because actually what you are doing when you are creating contract, your whole assembly code is one big constructor. So for example, first you are putting to the memory everything that needs to go on chain, and then for example you are calling this console log, then you are setting owner to storage, emit an event, and this is what you see. However, what is added implicitly by the compiler is, after executing all these instructions, you are returning code offset and code length to be deployed. So let's say that this is your code that has to be put on chain. So the code offset and code length of course, compiled functions will be put, and this will be your smart contract that is deployed on chain. So this is also the difference between the init code and runtime code. The init code is the one that initializes your smart contracts and returns the byte array to be deployed as your smart contract. And then runtime code is actually this. This is the byte array returned by the constructor. And actually, this is why you don't have constructor deployed on chain, because constructor is set of instructions what needs to be deployed on chain, and it by itself is not deployed. So for example, we have the transaction that is being sent from user. The message data contains the assembly to be deployed. So let's say that first we have the instructions what to really deploy, and this is the actual smart contract that will be stored on chain, which is actually, as I already said, everything but the constructor. So here also you have all the initialization of your immutables, of setting storage, emitting, even anything that you do in constructor. And in the end, you have to say, okay, now I will tell you this array, and this is what has to be put on chain. Well, actually, you also have this metadata of the smart contract. This is not really something that you will ever need, so I will just skip that. But now, what if you want to put some parameters into constructor? This is like normal stuff. We want to initialize our, for example, we want to initialize our immutable values. So this is actually really easy. What you do is you are putting all of the constructor parameters at the end. And then this initialization code will use those values, will modify this assembly that has to be put. And finally, this modified by the constructor will be stored on chain. Cool. Now let's see how we can call other contracts. Now, we can call, for example, smart contract with our message data, which is our ABI encoded input. Our two is recipient address, and this is how we call basically smart contract. And one thing that you have to know, first step when sending transaction is always call transaction. Then your smart contracts can, of course, call other contracts and decide to use different operations on call, but this is only possible from the smart contract. So now, what possible call operations do we have? We have 4 of them: call, delegate call, call code, and static call. And I will now describe what are the differences between them. So the most basic one is, of course, call. This is generally what externally owned account use when they are calling any smart contract. This is also what is by default call when your smart contract is calling other smart contracts. Let's say that you have contract A and B. Inside contract A, we have function, and this function performs some logic, and it calls b.some function. So by default, here the call will be used. So let's say that we have user that sends 100 weight to contract A, and then contract A calls contract B with 0 weight. So in case of call from A to B, the message sender of the call is in B is A, message value is 0, and it can modify the state in B. Okay, I'll add additional note here whose state is changed. It's B. So let's say if B changes some storage variables, the state change is applied to B. In case of delegate call, the situation is a bit different, because it looks like as if you were still inside of this contract. However, you took the executable code from contract B and take it and execute it as if it was your code. Okay, so let's, for example, see this code. If you are calling delegate call and we are encoding the change owner and we are setting it to address 0, what happens is message value is preserved from the calling context, the message sender is preserved. So you can think about it as if what we really did, as if we copy pasted this particular function and executed it as if it was this contract. Any change to storage will be applied not to the contract that we are calling, but to us. It's just like borrowing the logic of different contract to our contract. So in case of delegate call, here message sender, because as I said when I showed you the code, it's like as if you were still in this contract and you just borrowed the logic of this contract. So again, the message sender here, the message sender is user. The value is, well, if you ask for message value, it will tell you that it's 100 way, but here's a catch. You can see, for example, difference between call and delegate call, and the difference is that you do not have the value parameter. So the message value will be shown as if you send 100 way, but actually you are not really sending any value. So that means that if you call this contract via a delegate call, this contract will have 100 way and this contract will have 0 way. And you should be very careful when using that, especially in loops, because the message value will be set as, like, for example, 100 way, but actually no value is being sent in delegate call. The value is being stored in a contract. And actually, if you think about it, you are just borrowing the logic of this contract. So there is no value being sent. Concerning call code, this is like hybrid between call and delegate call. This is actually deprecated and you should not use it because its logic was the message sender was changed, the message value as well, but it behaved as if it borrowed the logic of different contract, and actually it had no real application inside of the EVM. No one used it, so they just deprecated it. And finally, we have static call. Static call is very similar to call instruction. So if you are calling from A to B, the message sender is set to A, the message value is taken from this call, but the biggest difference is that static call cannot modify the state. This is super useful. For example, if you have pure or view functions, you can make sure that the contract that you are calling cannot modify the state of the EVM. And of course, the state changes do not apply here. So yeah, that's all concerning the calling contracts. I hope that you learned something new and see you in the next one.